November 2, 1944, Bavarian Alps Test Airfield, Germany. Engineer Hans Molthopp stood on a frost-dusted tarmac, his breath fogging in the cold air. His gloved hand shaded his eyes as he watched the sleek, silver aircraft taxi toward the runway. The Arado AR-234B, Germany's first jet-powered bomber, gleamed under the overcast sky, its two Junkers Jumo 004B jet engines humming with a high-pitched whine unlike any propeller-driven plane. The pilot, Hauptmann Erich Sommer, gave a thumbs up from the cockpit. Molthopp nodded to the ground crew chief, who waved a green flag. The AR-234B lurched forward, accelerating faster than any bomber Molthopp had ever seen. It lifted off at 240 kilometers per hour, climbing steeply into the clouds. Molthopp checked his stopwatch. The plane would reach 6,000 meters in 8 minutes, half the time of a Heinkel He-111. This was the future of bombing. Fast, high-flying, and nearly impossible for Allied fighters to intercept. But it was arriving too late. The Arado AR-234B was a marvel of engineering, but Germany's collapsing industry and dwindling resources would keep it from changing the war's end. The idea of a jet-powered bomber emerged from Germany's early World War II jet research. As far back as 1938, the Reichsluftfahrtministerium, RLM Air Ministry, had funded projects to develop jet engines, seeing potential in their speed and altitude capabilities. By 1940, two companies, Junkers and BMW, were racing to build a viable jet engine. The Junkers Jumo 004, designed by Dr. Anselm Franz, was the first to succeed. Axial flow engine producing 8.8 knots of thrust, capable of propelling an aircraft to 800 kilometers per hour. In 1941, the RLM contracted Arado Flugzeugwerk, a small but innovative aircraft manufacturer, to design a bomber around the Jumo 004. The project was codenamed Eisenhammer, Iron Hammer, and it was placed under the leadership of Hans Molthopp, a 28-year-old aerodynamicist who had previously designed wings for the Focke-Wulf FW-190 fighter. Molthopp's team began with a clean sheet of paper. Unlike propeller-driven bombers, which relied on bulky engines and large wings for lift, a jet-powered bomber needed a streamlined fuselage to reduce drag and thin wings to handle high speeds. The first prototype, the AR-234V1, was completed in March 1943. It had a tubular fuselage 12.6 meters long, a 14.4 meter wingspan with thin, swept design 18 degrees at the leading edge. Molthopp's innovation to delay compressibility effects at high speed, and two Jumo 004 engines mounted under the wings. The cockpit was positioned high in the fuselage, giving the pilot excellent visibility for bombing. The bomb bay, located in the belly of the fuselage, could carry 1,000 kilograms of explosives, enough for a single 1,000 kilograms SC-1000 bomb or 4 250 kilograms SC-250 bombs. The first test flight of the AR-234V1 took place on June 15, 1943, piloted by Flugkapitän Sigmund John. The plane reached 740 kilometers per hour at 6,000 meters. Faster than any Allied fighter then in service, the Spitfire Mk9 topped out at 657 kilometers per hour. But the Jumo 004 engines were unreliable. They overheated after 30 minutes of flight, and their turbine blades were prone to cracking under stress. On July 28, 1943, the AR-234V1 crashed during a test when one engine failed. John ejected safely, but the prototype was destroyed. Molthopp's team revised the design, strengthening the engine mounts and adding better cooling ducts for the WWII. The second prototype, the AR-234V2, flew in September 1943 and completed 12 successful test flights before being grounded for engine upgrades. By late 1943, the RLM was growing impatient. Allied bombers were hitting German cities daily, and the Luftwaffe needed a bomber that could avoid interception. The Arado team was ordered to speed up development, with the first production model, the AR-234B, scheduled for delivery in April 1944. The B model featured several improvements over the prototypes. More powerful WWII-04B engines, producing 9.8 knots of thrust each, a reinforced fuselage to handle heavier bomb loads, and a primitive radar altimeter to help with low-level bombing. It also had a crew of one, the pilot, who doubled as navigator and bombardier, a decision made to save weight and space. Building the AR-234B was a logistical nightmare. The plane's fuselage was made of duralumin, an aluminum-copper alloy that was lighter and stronger than steel, but harder to machine. Arado's factory in Warnemund on the Baltic coast had to install new hydraulic presses to shape the curved fuselage sections. Each section was riveted together with 15,000 aluminum rivets, each sealed with rubber gaskets to reduce drag. The wings were even more complex. They were built in two pieces with a spar central support beam made of high-strength steel and skin made of duralumin sheets 1.5 millimeters thick. The WWII-04B engines were shipped from Junkers' factory in Magdeburg, but they arrived with frequent defects. 1 in 3 engines failed their initial test runs due to poor quality control. The most critical component was the jet fuel. The WWII-04B ran on J2 fuel, a mixture of 50% gasoline and 50% diesel, which was in short supply. Germany's oil refineries, targeted by Allied bombers, could only produce 20,000 tons of J2 fuel per month, enough for 1,000 AR-234B sorties, but far less than the RLM's demand of 5,000 sorties per month. To conserve fuel, test flights were limited to 45 minutes, and pilots were ordered to fly at 6,000 meters, where the air was thinner, reducing fuel consumption whenever possible. By April 1944, only 10 AR-234Bs had rolled off the production line, half the RLM's target. The Warnemund factory had been hit by British bombers in March 1944, destroying 20% of production line. Arado was forced to relocate production to a network of underground factories near Dresden, where workers toiled in caves 50 meters below the surface, with no natural light and poor ventilation. The move delayed production by 2 months, and the first AR-234BS did not reach frontline units until July 1944. If you found this interesting, give a thumbs up to show your support. Drop a wonderful in the comments to let me know you're still with me. Stick around till the end, because I'll reveal 3 mind-blowing facts you won't want to miss. Haven't followed yet? Hit that follow button so you won't miss our next deep dive. Trust me, the best is yet to come. The first operational unit to receive the AR-234B was Camp Jeschwiter 76, KG-76, Bomber Wing 76, based at Oranienburg Airfield near Berlin. The unit's pilots, all veterans of propeller-driven bombers like the He-111 and Ju-88, were stunned by the AR-234BS performance. On July 25, 1944, Hauptmann Erich Sommer flew the first combat mission in an AR-234B, reconnaissance over Allied positions in Normandy. He flew at 8,000 meters at 780 kilometers per hour and returned without being detected by Allied radar or fighters. "It's like flying above the war," he wrote in his mission report. Over the next month, KG-76 flew 50 reconnaissance missions in the AR-234B, gathering intelligence on Allied troop movements without losing a single plane. The AR-234B's first bombing mission took place on August 28, 1944, against Allied positions near Paris. For AR-234Bs took off from Oranienburg, each carrying a 1,000 kilograms bomb. They flew at 7,000 meters, avoiding 3 squadrons of P-51 Mustangs that tried to intercept them. The Mustangs, with a top speed of 703 kilometers per hour, could not catch the AR-234Bs, which pulled away easily. The bombers dropped their bombs on Allied supply depot, destroying 50 trucks and an ammunition dump before returning safely. The mission was a success, but revealed a flaw. The AR-234B's bomb sight was primitive. The pilot had to estimate the release point using a simple optical sight, and only 20% of bombs hit their targets. Molthop's team added a more advanced bomb sight, the LOP-7H, to later models, improving accuracy to 40%. By September 1944, KG-76 had 25 AR-234Bs, but the unit was struggling with maintenance. The Jumo 004B engines had a lifespan of only 25 hours. After that, they had to be replaced. Spare engines were scarce, and many AR-234Bs sat idle on the tarmac, waiting for parts. The underground factories near Dresden could only produce 10 engines per week, not enough to keep up with demand. To make matters worse, Allied bombers hit the Junkers factory in Magdeburg in October 1944, halting engine production for 3 weeks. The AR-234B's greatest strength, its speed, also became a liability. At high speeds, the plane's controls became stiff, making it hard to maneuver. Pilots called this the wall. At 800 kilometers per hour, the ailerons, wing flaps returning, required twice the normal force to move. On October 5, 1944, Lieutenant Walter Krauss crashed during a training flight when he could not adjust the ailerons quickly enough to avoid a stall. He ejected but suffered serious injuries. Molthop's team added small trim tabs to the ailerons, reducing the force needed to move them, but the problem persisted at speeds above 820 kilometers per hour. Another issue was the plane's landing gear. The AR-234B had a retractable tricycle gear, uncommon for German bombers, which made landing easier but was prone to failure. The front landing gear often collapsed on rough runways, damaging the fuselage. Ground crews added reinforcement bars to the gear, but the problem continued. By November 1944, 5 of KG-70SX's 25 AR-234Bs were out of service due to landing gear failures. The RLM had big plans for the AR-234. A more advanced model, the AR-234C, was under development with 4 BMW 003 jet engines, each producing 8.3 knots of thrust, which would increase speed to 870 kilometers per hour and bomb load to 1,500 kilograms. A reconnaissance version, the AR-234B-1, carried cameras instead of bombs and could fly 1,800 kilometers on a single tank of fuel, enough to reach London and return. There were even plans for a night fighter version, the AR-234N, equipped with radar and 20mm cannons to hunt Allied bombers. But none of these models would see widespread service. By December 1944, Germany's industrial base was collapsing. The underground factories near Dresden were running out of aluminum, and workers were being drafted into the army. The AR-234C prototype flew in November 1944, but only 10 production models were built before the war ended. The AR-234N never left the drawing board. KG-76, now based in Bavaria to avoid Allied bombing, had only 12 operational AR-234BS by January 1945. The unit flew its last major mission on February 14, 1945, bombing Allied bridges over the Rhine River. 3 AR-234BS were shot down by P-47 Thunderbolts. Allied fighters had been upgraded with more powerful engines, allowing them to reach 760 kilometers per hour, close enough to intercept the AR-234BS if they caught them at low altitude. The final days of the AR-234 program were marked by desperation. In April 1945, as American troops advanced into Bavaria, Arado engineers destroyed most of the remaining AR-234BS to prevent them from falling into Allied hands. A handful were flown to Switzerland, where they were interned. The last AR-234B to fly was piloted by Hauptmann Erich Sommer on April 25, 1945, a reconnaissance mission over Munich. He returned to find the airfield under attack by American tanks. He landed, set the plane on fire, and surrendered to American troops. After the war, Allied forces captured several AR-234BS and AR-234CS, including the prototype AR-234C3. They were shipped to the United States and Britain for study. American engineers at Wright Field in Ohio were impressed by the AR-234BS design. The swept wings, jet engine layout, and streamlined fuselage would influence post-war bombers like the Boeing B-47 Stratojet. British engineers at Farnborough Airfield noted that the Jumo 004B engine was a remarkable achievement, though its short lifespan made it impractical for long-term use. Hans Molthopp, the AR-234's chief designer, surrendered to American troops in May 1945. He was brought to the United States under Operation Paperclip, a program that recruited German scientists to work on American weapons projects. He worked on jet engine design for the U.S. Air Force until 1950, then returned to Germany to teach aerodynamics at the Technical University of Munich. He never spoke publicly about the AR-234's failure, but in a 1972 interview he admitted, "We had the right idea, but we were too late. The war ended before we could build enough planes to make a difference." The AR-234's legacy is a study in what might have been if Germany had developed a jet engine earlier, if production had not been disrupted by bombing, if fuel and spare parts had been available. The AR-234 could have changed the course of the air war. Its speed and altitude would have made it nearly invulnerable to Allied fighters in 1944, allowing German bombers to hit Allied supply lines and cities with impunity. But Germany's late start, resource shortages, and strategic mistakes doomed the project. The AR-234 was a weapon ahead of its time, but arrived too late to save the Third Reich. Today, only a handful of AR-234 survive. One AR-234B is on display at the Smithsonian National Air and Space Museum in Washington, D.C. Its silver fuselage still bearing the scars of combat. Another is at the Deutsches Technik Museum in Berlin, where visitors can see the Jumo 004B engines up close. A third is at the Royal Air Force Museum in London, painted in the colors of KG-76. The plaques next to these planes tell the same story. A brilliant design, a failed deployment, a reminder of WWII's technological race. The AR-234 story also speaks to the limits of technology in war. Even the most advanced weapon cannot win a war if it is not produced in sufficient numbers, its crew is not trained properly, if its supply lines are cut. The AR-234 was faster and more advanced than any Allied bomber, but it could not overcome Germany's collapsing industry and dwindling resources. It was a symbol of German engineering genius, but also of Nazi Germany's strategic overreach. As visitors to the Smithsonian stand before the AR-234B, they often marvel at its sleek design, at the power of its jet engines, at the vision of the engineers who built it. They wonder what would have happened if the plane had arrived in 1943 instead of 1944. Would it have delayed the Allied invasion of Normandy? Would it have forced the Allies to divert resources to air defense? We will never know. What we do know is that the AR-234 was a glimpse of the future, a future where jet-powered bombers would dominate the skies, a future that arrived too late for Nazi Germany. The AR-234BS engines are silent now, its bomb bay empty, its cockpit dark. But it remains a powerful reminder of WWII's technological revolution, of the race to build weapons that could change the course of history, and of how even the most brilliant ideas can be undone by the harsh realities of war. It was a bomber that could have changed the war's end, if only it had arrived in time.